All right, in this video we're going to look at orthogonal projections. So you saw in your HL course that orthogonal projections are used when we want to find the distance from a point to the line. So we look for the perpendicular projection of the point onto the line. So here we've got a line that is our y equals tan alpha of x. So we've got our alpha angle down in here. And then we're going to look at our transformations of our standard basic unit vectors. So we're going to look at projecting this point onto the line perpendicularly. So there's a right angle here, and then I'm also going to put in a right angle here to help with our trigonometry. So if we look at this right triangle here, then I'm going to tilt it around to look at our distance. So we've got our right angle here. This is our hypotenuse of 1. And then we have our alpha angle is going to be down here. So now I see that this is going to be, if we call this x and we call this y, our x is going to be cosine of alpha and our y is going to be sine alpha. So we can come in and label these sides. So here we've got cos alpha, sine alpha. Now if I look at this right triangle here, so looking at that one, now we have angle alpha, and this is cos alpha down here on my short side. So if I call this side y and this side x, oh, sorry, cos alpha is not there. Cos alpha is my hypotenuse of this triangle. All right, so x over cos alpha is also equal to cos alpha. So our x side is cos squared alpha. Our y side, so sine of alpha is y over cos alpha. So y is sine alpha cos alpha. I'm just going to abbreviate there. So now I can write my vector here, cos squared alpha, sine alpha, cos alpha. All right, I'm going to do something similar to find my transformation of 0, 1. Again, I'm going to look at triangles. So I'm going to take this, move it, take this, shrink it down some. Okay, so now I'm going to look at projecting 1, 0, 1 onto my line. So again, I have alpha here. That means this is going to be pi over 2 minus alpha. We know that this is a right angle as well. So here, pi over 2 minus alpha. This one must be alpha. That means this one's pi over 2 minus alpha. This angle in here is also alpha. Starting with my bigger right triangle again, I have a hypotenuse of 1. So this side here must be cos alpha. This side here must be sine alpha. So looking at this smaller right triangle, I have a hypotenuse of sine alpha. Here's my alpha angle, sine alpha. This side would be cos alpha. This side would end up being sine alpha cos alpha. And then this side down here is going to be sine squared alpha. So looking at putting these two things together, I've got my x coordinate is sine alpha cos alpha. So let's move this back down over here. sine alpha, cos alpha, and then my y value corresponds to here, sine squared alpha. So putting these two together, I have my total transformation matrix, cos squared alpha, sine alpha, cos alpha, sine alpha, cos alpha, and sine squared alpha. Okay, so there's my projecting in 2D onto a line y equals tan alpha x.